What's up, guys? Welcome back to another video on MySQL Workbench. In this video, we're going to talk about some intermediate level concepts. First, we will introduce about the concepts, and then we talk about primary keys, why primary keys are important, and how do we set up the primary keys, and then we'll work on the foreign keys. Both the primary key and foreign key help us create connections between two tables. We'll take the employees table and a department table and see how we link them together. And then we talk about relationship basics, the one-to-many relationships and many-to-many relationship that exist between the data tables. Then we explore the joins, the left join, right join, and the inner joins. And then we'll talk about common primary key and foreign key violations. Then we will talk about working with views, and then we try to understand about models in MySQL Workbench, and then we'll conclude the video and talk about next steps. So without any delay, let's dive into the video. Yeah, we'll go ahead and create new columns. If you look at our previous database ready controls, we selected that and we are using that database right now. So we'll go ahead and create necessary tables. This is the query. You can follow my previous video which talks more detail about these commands. So we create a new table called departments with department ID not being null and auto increment, and we make it a primary key for this table. And we'll go ahead and create the table by running it, and you can see we have a table called departments now with two columns in it, department ID and department name. Now we go ahead and create a employees table where I'm defining ID, which is an integer data type, and not null auto increment, which is the primary key. And then we have a first name and last name with varchar of 15 not null, and a department ID not null. And we put some constraint on the salary not being salary being positive, and it's not null. And we have a hire date of date data type, and we have a status called bool. This is where we established a foreign key concept which links this table to the departments table. Foreign keys and primary keys both establish relationship. The primary keys are used for database management. They're essential for organizing the data and data integrity. It also helps us prevent duplicate entries, and foreign keys help us link the tables, right? And that's how we did it. When we create the employees table, we went ahead and selected like linkage to the employees table to the departments table is via this foreign key. So we went ahead and added a foreign key relationship by using this constraint foreign key. Department refers to department's dep ID and delete cascade and update on delete cascade and on update cascade. So now we established both the tables. We'll go ahead and refresh the schemas and see both the tables. We have an employees table which has department ID, and we link this department ID to this dep ID in the departments table. Now we go ahead and populate it with some sample data. First run the departments. We have 10 rows affected, so we'll go ahead and check the data. We created 10 departments, which we created these 10 departments. Now we go back and use the multi-insert and insert data into the employees data. So we go ahead and run that, and to check that we'll again right click and find out all the data, and we have these. Now is that we have both the tables created and we have some data in it. We will talk more about join. So cross join. So to understand cross joins, this is a Cartesian product and it's no condition. So let's understand what we get when we run this select star from employees on with cross join on departments. So we'll go ahead and run that query. When we ran it, type of a join that returns the Cartesian product of two tables. That means it combines every row from the first table and with every row from the second table. So for example, if the first table has 2 rows and the second table has two rows, you would get a total of 4 rows. It does not require a common key between the two tables. So it just generated all the possible combinations. It can be useful to generate all the possible combinations. Now we'll look at the next type of join called inner join. Inner join is used to combine rows from two tables based on a related column. It returns only the rows where there is a match in both the tables. So we run this query. We select employees dot first name, employees dot last name, departments, and we take the departments table and take the department name from employees, departments dot department name from employees, and we inner join departments on employees department id equal to dep id. Let's see. Returns Inner join returned only all the rows where there is a match between the department id from employees and dep id from departments. Combining information from related tables, if you want to retrieve only matching records, inner join is the way to go. And that inner join condition is on employees department id matches to departments dot department id. Now we'll talk about left join. Left join is also known as left outer join. It returns all the rows from left table and matched rows from the right table. If there is no match in the right table, the result will contain null for all the columns from the right table. So we'll go ahead and look at this syntax where we select employees first name and last name and department name from employees table, and we left joining it to left join departments on employees table with the column department id is equal to departments dot dep id. So this is where our left join is specifying the conditions to match rows from both tables. So when we run this query, let's see what the output looks like. Left join, we get all rows from employees table, which is the left table, all rows from employees table, even if there is no matching departments in department table. So right now we don't have that condition, but it gave us all the to keep all the records from left table even when there is no match in the right table. That's where we use the left join. Right now it gave us all the rows from the left column. Why use left join? To keep all the records from left table is where we use it, and it is useful when you want to include records from one table, which is the left, and only matched ones from the other table, which is the right one. Okay, and now we'll go ahead and run a right join on the same one. A right join, also known as a right outer join, is used to combine rows from two tables based on a related column. It returns all the rows from the right table and matched rows from the left table. If there is no match in the left table, the result will contain null for all the columns from the left table. Let's look at this query. We are selecting employees first name last name from employees table, and we are right joining departments on, so departments is our table 1 on the column department id. Employees department id is equal to departments dot department id. This condition specifies to match rows from both the tables. Let's run this. When we run this, we got all the rows in department. The right join returned all the rows from departments table, which is the right side of right table, even when there are no matching employees in our employees table. Right now we don't have any employees who has no department. That's why it's returning all. But where do we use the right join? It's useful to keep all the records from the right table and include the matched rows from the left table. Show some examples of primary key violation. What we did here is we inserted a record with employee id 1, first name John, last name Doe. Let me zoom in, sorry. We inserted one record with department id and employee id 1. Now we'll try to insert a duplicate record with the same name but into a different department. we use the same employee ID and we created we want to insert into new department. Then we immediately got a duplicate entry error for primary key, duplicate entry error for primary key employees. Yeah, that's how we prevent adding duplicate entries with same employee ID. Okay. Now what we'll try to show one more example. Let's about a missing reference on the foreign key. So this is a missing reference on the foreign key. We are inserting into employees table first name, last name, department ID, and salary, and let's see what will happen. Note the department ID is 999, which does not exist in our departments table. If we look at our departments table, we don't have a 999 and we're trying to insert a record with the department of 999. Okay, when we run that, it says cannot add a child row. Let's zoom out to see this. It says cannot add or update a child row, a foreign key constraint fails. Okay, so that's it. That's how you restrict data entry without having a proper department ID. So that's the constraint which we use. Next, understanding view. What is a view? A view is a saved SQL query that acts as a virtual table. It helps simplify complex queries by allowing users to reference a view instead of writing a long query each time. Creating a view for employee details. So let's go ahead and create a view for employee details. So you can see this is the query which we are looking at. This is creating a view. So we use the command called create view employee details is the name of the view. As we go ahead and select e.id, e.first name, e.last name, and e.salary and d.department from the employee table E, and we join the departments D table on employees.department ID equal to departments d.department ID. So we'll go ahead and create this view by running this command. So I have an error when we run this. Let me zoom out, and it's saying employee does not exist. There is a typo in this one. Our table name is employees instead of employee. So just a small troubleshooting. So we go ahead and put the S there and go ahead and Now the query ran and we created a view. To see the view, all we do now from anytime is we go ahead and do select star from employee details. Instead of running that big query, we just run this, which will give us all the employee details. Rather than using this big query, we just created a view which we could just run in one single line. Okay. Now we talk about data models. Understanding data models. In SQL Workbench, a data model visually represents your data schema, making it easier to understand the relationship between tables. So far we have created two tables, the employees and departments. Employees table store individual employee details. The employees table store all the individual details. So we'll go ahead and see. So it has all the individual details, and the departments table has each department details, right? Now and we link them with a foreign key and a primary key. To view the model in MySQL Workbench, we will click on this. We'll click on this database and right click. We refresh all and we click database and use reverse engineer, and we have this window which pops up. I will bring in. This window comes up and we select. Let's zoom out so you can see. And we hit next. We connect to the database, and then it's connecting to the database, and we select the database which we want to build the entity relationship diagram, and we hit next, and it will place the object, and it's saying operation successful. So go ahead, hit next and finish. And now we can see take the hand tool and drag it up, and you could see the relationship between the two tables with a foreign key. Let's see if I can zoom into that. Yeah, I'll just go back to the main. Okay, but you could see here, you can see how the relationship is being shown between department ID and dep ID in that. That's how you show the models. This is called entity relationship diagram. There are several tools to make entity relationship diagram. Typically you start with the model and then create the data tables, and we will discuss about that in the next video. If you like this video and if you think it helped you, please do like, share and subscribe to my channel. We'll see you in the next video.